Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azlin bin Muhammad Azhar. My number matic is 8822000854. Today, me and my other teams are going to present the lab sheets that are we going to do in control system course. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azmin bin Muhammad Azhar. My number matic is 88200854. Today, me and my team are going to present the lab sheet 2 in control system. So first of all, my part is lab activity 1, which I need to convert the following frequency domain expression into time domain using MATLAB command. So first of all, open the MATLAB. You will see like this, the command window and other part, and then you go back to the lab sheet. As you can see, my job is I need to convert the following frequency domain expression into time domain using MATLAB, right? So first of all, you type sims s because I did the command at first for this part, and then copy the equation s plus 2 divide by s to the power of 2 minus 3s. So will be like this. Is the format command in for the command window, and then press enter. It will be like this: h equal to negative s plus 2 divided by negative s to the power of 2 plus 3s, and then press enter and type I Laplace because our job is need to convert progress domain especially into time domain, right? So we need to use inverse Laplace in this part, and then press enter. It will give the answer, which is 5 expression 3t divided by 3 minus 2 over 3. So that's for the question number 1 in activity 1. So we go to the question number 2, which is I need to convert the following time domain expression into frequency domain using MATLAB command. So in the same way, type the sims t, right? And then press enter. After you press enter, copy the equation inside the equation of number 2. The equation is yt equal to 1 minus 2e to the power negative 2t plus e to the power negative 8t. And then press enter. It will give the 1 minus negative 8t minus 2 expression negative 2t. And then you press enter again. Because our job is to convert the following time domain expression into frequency domain. Yes, it's different a little bit from the question number 1. So for this question number 2, we just using Laplace. And then after you type Laplace y, you press enter, it will get the answer like this: 1 divided by s, negative 1 divided by s plus 8, negative 2 divided by s plus 2. So that's all for activity number 1. I will pass activity number 2 to my friends Amirul Shafiq. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Shafiq, and I will continue the lab 2 for activity 2. Firstly, we must create a new Simulink model based on the diagram in lab sheet given. We can find the step, we can find the all component, which is steps, sum, gain, transfer function, marks, and 2 workspace at library browser. After that, we must check the step and we must make sure the step time is 0. Then the gain is 1 and the transfer function we set up like this. After that, we just run the simulation and we go to the command windows and we write all this: plot, output, time, output, signals, and value. And then this is the command, and you just click the enter, and this is the graph, the graph for step response for gain 1. After that, for the gain 2, we just change like this, and then we run the simulation, and then we just paste at the command window with the use the same command. Then we get the step response graph for gain 2. To the next, just change to 10 and run the simulation and use the same command. Then this is for step response graph for gain 10. Next, we must change the step input with the RAM input. Just delete it and find at library browser. Just find RAM. Then we just drag to here and just the gain is still same 10, and we run the simulation first and then use the same command also, and this is the graph for step response with RAM input. So this is the result when we zoom in at t equal to 10 seconds. Next, I will continue the presentation with the step response graph, but in root locus. We use the same system like before. We don't change anything. But in the command window, we write like we change a little bit like this. And before that, we must run first the simulation, and we just write like this and click the enter. And this is the root locus graph for step response. After that, we want to plot the gain at 1, 2, and 10. And here is the root locus gain 1, root locus gain 2, and root locus gain 10. And I think that's all from me, and I will pass the presentation to my friend back. Thank you.
So my part, for the next part, for the lab activity 3, I will do this part, which is in this activity 3, we need to record the step response, frequency box plot, and root locus for the system based on this circuit. So first of all, we need to open the MATLAB here. So after you open, for this part, we need to find the G, H, and T. Find the step response, frequency response, and root locus. So for the first one, we need to find G. After we insert the command in the MATLAB, you press enter, and then you will get this answer, which is 10s plus 20 divided by s to the power of 3 plus 2s to the power of 2 minus 3s. For same as other H, same as H, we insert the command here, and then we get the answer. It's like this, s plus 1 divided s plus 3, and then continue to the T, we insert the T, the feedback GH, and then we get the answer like this. So after that, after we insert all this command in the MATLAB, we need to find the step response, frequency response, and root locus for the system, right? So first of all, we need to find step response. We need to type step T, step, and open, close the big T, and then press enter. So we wait. It will show the graph. So this is the graph for the step response. And then for the next, we need to find the root locus. So we just type R locus T, then press enter. we wait for the graph for the root locus, and you can see this is a root locus graph. So for the last one is frequency response or the bot plot. So we type PODE, then press enter. So we wait. So as you can see, this is a bot diagram, which is a frequency response graph. So that's all from me and my team, Amul Shafiq, for the lab sheet explanation. I hope we can do better at the next time. Thank you. Assalamualaikum warahmatullahi wabarakatuh.